In this demo, we will show how to connect an industrial device to an IEC-energy protocol using the Anybus SG-gateway. The Anybus SG-gateway comes in three different versions. One for devices with digital I/O, one for M-bus devices, and one with an Anybus COM interface, meaning that it can handle devices using any fieldbus or industrial Ethernet network. In this scenario, we're using the I/O version of the SG gateway to connect a Modbus RTU slave called I/O extender to a power grid control room using IEC-6870-5104. So let's have a look at how it works. I start by running the chip tool software, which is included in the product package from HMS. This enables me to find out the IP address of the gateway on the network. I can see that the address is 192.168.1.10. So I can now start my web browser and enter this IP address to access the gateway. In this web interface, I will now configure my gateway. The initial starting page shows some information on input values, output values, and device information. To configure the gateway, we will need to go to the Settings area. First, we have to enter our user and password, which by default are HMS and HMS. The first thing we see is a log of events and any possible errors. In this demo, we wanted to add our I/O extender, which is a Modbus RTU slave, so therefore I will configure the Anybus SG gateway as a Modbus master. To do this, I go to the Modbus Master tab, where I first click Enable RTU. I set the mode to be RS485, my baud rate to be 9600, and the parity to be none. This is all according to the manual of the Modbus device, in this case the I/O extender unit. I now click Add Device and call it I/O extender. We say that it is an RTU slave and that we want this on address number 1. So now the I/O extender appears in the list, but it is empty since we have not assigned any registers yet. To do this, I click Add Value. I call this value Digital Input 1 and state that it should be a read coil status. We know from the product manual that the start address is 0. We want it to read one register of the type Boolean. So we click OK and can see that the register now appears here in the configuration. To add another register, I can click the Clone button and then Edit to go in and adjust the second input register of my I/O device. I also add a third register, in this case an analog input on start address number 5, and it's a 16-bit unsigned integer. Okay, the next step is that I want to add 2 outputs. So I click Add Value again and enter Digital Output 1. It has the function Force Multiple Coils, starts on address 16, it is 1 register long and has the data type Boolean. This now shows up in the output section. I clone this to add a second digital output. This is all we need to do on the Modbus side, so we click OK and then reboot the gateway to load the configuration. Now we can go over to the other side of the gateway, the IEC configuration. So I click on the IEC-6870-5104 server tab. I click Add to add a signal and then enter the name, which I set to be Power. I state that this should be a measured value with the function 9 from the IEC-104 protocol. I also want to give this signal an address on the 104 side, so I pick address number 1, enter the range to be 1, and also that I want a cyclic transmission time of 1 second. So now we see that this has been defined as an output, ready to communicate with an external client. We can now click OK and reboot the gateway for these changes to be applied. This concludes the configuration of the gateway, and we can now go on to the application where we set up the data flow between the Modbus device and the control room. I do this by clicking on Editor. Here we can program our application. I go to this drop-down menu where I find my I/O extender under Modbus Master. Here I can select the 3 registers that we set up earlier: the analog input, the digital input 1, and the digital input 2. Our output registers can be found under Modbus Master, so I insert our digital input 1 and digital output 2. And finally, we also see our IEC-104 server with an information object called Power. Now I can easily map my connections by simply dragging lines between the different inputs and outputs. For example, I can connect the analog input from my Modbus slave to the 104 output. We can even map the digital input of the Modbus slave to the digital output of the same device. When I'm done with my mapping, I can click the Save button. I can see that the traffic light on the top right-hand side is yellow, meaning that the application is stored, but it's not running yet. So I click the Start button, and I can see that live values show up in my editor. If I turn the physical knob on my Modbus device to change the voltage, I can see that values change in my editor. Just to show you the data flow, I will start an external IEC-104 client software called QTester, where I can view the data flow. I click Connect and enter the IP address, which was 192.168.1.10. I check that I want to see the log, and I can now see that data is being sent between the Modbus device and the power control room using IEC-104.